A warm welcome to one and all. In this talk, I am going to outline the basic aspects of Lee-Santilli iso theory, which are essential for Santilli's proof of EPR argument, showing incompleteness of quantum mechanics and subsequent development of hadronic mechanics by Professor Santilli. Santilli has shown the possibilities of generation of clean intermediate energies without triggering heavy element fission and radioactive waste. Coming to the first slide, titled EPR argument. The famous EPR argument proposed by Einstein, Podolsky, and Rosen in 1935, as stated above, was advanced as an argument that quantum mechanics is not a complete theory and should be supplemented by hidden variables to make it complete. They suggested that quantum mechanics could be completed into a form recovering classical determinism, at least under limit conditions. However, the hidden variable interpretation of quantum mechanics was found to be grossly non-local, and this appears to disprove EPR argument. In 1978, R.M. Santilli discovered the action-preserving generalization, that is completion, of various branches of Lee's theory, universal algebras, Lie groups, etc., by defining a spatial iso-associative product and classifying isoalgebras into regular and irregular isoalgebras according as the structure constants are constants or functions. Subsequently, Santilli proved that Einstein's determinism is progressively approached in the structure of hadrons, nuclei, and stars, and is fully recovered at the limit of gravitational collapse. But the treatment for disproving EPR argument were under generally tacit assumptions of point-like particles moving in vacuum under sole potential Hamiltonian with action at a distance potential interactions. When the systems are treated via quantum mechanics with underlying 20th century mathematics, including Lee's theory and Newton-Leibniz differential calculus. However, the same treatments are not applicable for interior dynamical systems, wherein extended, deformable, and hyperdense particles moving within resistive medium with action at a distance plus contact non-potential, non-local forces under condition of mutual penetration or entanglement that occur in the structure of hadrons, nuclei, stars, and gravitational collapse, such as black holes. For appropriate treatments for interior dynamical systems, Santilli proposed and formulated new mathematics called as isomathematics, which is the action-preserving lifting of 20th century mathematics applicable to interior dynamical systems. We recall fundamental interactions, which are Hamiltonian, non-Hamiltonian, and strong nuclear interactions as follows. Hamiltonian interactions are the linear, local, derivable from potential, and hence fully representable by conventional Hamiltonian. Whereas non-Hamiltonian interactions are interactions that are non-linear, non-local, and non-potential. Coming to the next interaction, known as strong nuclear interaction. These are the interactions which have a conventional potential, thus Hamiltonian component, and a new contact, thus non-zero range and non-Hamiltonian component. In addition to four known contact interactions as stated above, namely friction, applied force, normal force, and tension, Santilli proposed fifth type of interaction to its purpose as stated in this slide. EPR entanglement has been experimentally proved to hold at arbitrary classical distances, whereas in fifth interaction suggested by Santilli, non-linear, which is non-local, non-linear, continuous, and instantaneous at arbitrary distances due to overlapping of wave packets of particles. Importantly, quantum mechanics is known to be reversible over time, whereas nuclear fusions are known to be irreversible. Further, Santilli devoted his research in the completion of quantum mechanics via Lie admissible generalization of Lie's theory and Heisenberg's equation. So, in quantum mechanics, it is reversible over time, whereas nuclear fusions are known to be irreversible over time. Experimental evidence showed that compressing proton and neutron into each other reduces delta R and delta P, which are the standard deviations for position and momentum, to be smaller than their atomic counterparts. That is, stronger the nuclear forces, weaker is the uncertainty. According to Copenhagen interpretation, the sole possible representation of particle entanglement is where particles are free with sole possible interactions that are derivable from a potential which is identically null for particles at large mutual distances. Santilli pointed out rightly that the sole interactions that are continuous, instantaneous, and are at arbitrary distances are given by mutual penetration of packets of particles, which being non-linear, non-local, and non-potential cannot be treated via quantum mechanics. Now coming to Einstein's indeterminism, isodeterminism. Einstein's isodeterminism is a rigorous formulation of uncertainties under strong interactions. Today, hadronic mechanics gives exact and invariant representation of experimental data, which is not represented by quantum mechanics. So, hadronic mechanics is intended to denote a mechanics of strong interactions. Santilli's hadronic mechanics has been verified in virtually all physical fields by the exact and invariant representation of experimental data, generally not representable by quantum mechanics. Lie isotopic branch of hadronic mechanics. Systems of extended protons and neutrons under condition of partially mutual penetration in nuclear structure verify following properties. It admits explicit concrete realization of Bohm's hidden variables, violates Bayes' inequalities, and verifies broadening of Heisenberg's indeterminacy principle into iso-uncertainty principle of hadronic mechanics. Lie admissible branch of hadronic mechanics is for the representation of irreversible processes and for open interior systems. Santilli in 1978 submitted an action preserving broadening of 20th century mathematics known as isomathematics, also called as the isotopic lifting, based on the associativity preserving generalization of conventional product A cross B between generic quantities A and B, such as numbers, functions, matrices, operators, etc., and called the product. The product isoproduct is defined by equation 1. A cross B isoproduct is defined, isoproduct is written like this: A cross B cross hat, A cross hat B equal to A cross T hat cross B, where T hat is greater than 0, is an isotopic element, which is a special element. And it's crucial to note that in isomathematics and isomechanics also, the isotopic element T hat is much lesser than 1. So T hat can be written in this manner. Equation 2. It depends on x, v, e, mu, tau, psi, del psi, etc., where these are coordinates, velocities, energy, density, temperature, pressure, wave function, and their derivatives, etc. And T hat is a positive definite quantity. The above assumptions immediately allowed explicit representation of protons and neutrons as being extended, non-spherical and deformable charge distributions via realization of isotopic element of type 2. Again, coming to isomathematics, Santilli introduced introduced the isotopies f hat of the conventional numeric fields f, characterized by isoproduct 1 and with the generalized multiplicative unit called as iso unit, defined as iso unit 1 hat is equal to 1 over t hat, which is always greater than 0. And it leads to generalized numbers called iso-real number, iso-complex numbers, iso-quaternionic, iso-numbers, and related axioms, where n hat is equal to n into 1 hat is an iso number, where 1 hat is the iso unit as defined above. With consequent formulation of iso-associative algebras on an iso field with iso-complex, iso-quaternion, iso numbers, and lifting of functions to iso functions and iso exponentiation, etc. Iso brackets, that is iso commutators, were also defined by Santilli in this fashion. Iso commutator x y is equal to x star y minus y star x equal to x t hat y minus y t hat x, where t hat is again the isotopic element, and this is today known as Lee-Santilli isotheory. So the action-preserving lifting of quantum mechanics into isotopic branch of hadronic mechanics, or simply isomechanics, is formulated on Hilbert Muon Santilli isospace H hat over the isofield of isocomplex numbers C hat. Heisenberg's uncertainty principle prohibits a structural representation of synthesis of neutron from electron and proton in the core of stars, whereas the study of neutron synthesis via hadronic mechanics under iso-unitary principle as derived by Santilli implies standard iso deviations, allowing a quantitative representation of neutron synthesis from hydrogen with far-reaching advances that cannot be formulated in quantum mechanics. So exact validity of Heisenberg's uncertainty principle was questioned by Santilli in 1977. His argument was that Heisenberg's standard deviations of coordinates delta r and momenta delta p and their product are certainly valid for point-like charged particles under electromagnetic interactions. But when considering extended nucleons in the condition of mutual penetration, the situation is quite different. And the standard deviations delta r and delta p for electron in vacuum and for nucleons can't be the same. This gives rise to need for suitable completion of Heisenberg's uncertainty principle for strong interactions. So Heisenberg's iso equations defined by Santilli is following. See number 6, equation number 6. The Heisenberg iso equations for time evolution of Hermitian operator Q in infinitely small form is given by this equation. And unitary transforms are defined in this manner. Equation 7 and equation 8. 7 is the finite form. Isocalculus was initiated and developed by Professor Santilli, which permits Schrodinger iso representation characterized by fundamental representation of iso momentum given by equation 9, from which one can derive iso Schrodinger equation as follows. This is iso Schrodinger equation, where I hat star del hat I operating on iso wave function is equal to E operating on psi hat t hat r hat, and which ultimately equals to E operating on psi hat t hat r hat, where E hat is E into I hat. is an iso eigenvalue defined over iso real field R hat, and E is an ordinary eigenvalue defined over the field of real number. Iso commutation rules were also defined by Santilli, which are defined in this manner. Equation number 11. Finally, iso-Schrodinger equation, as developed by Professor Santilli, can be written in this manner. This is known as iso-Schrodinger equation. Equation number 13. H iso product operating on psi hat is equal to H t hat operating on psi hat, again E operating on psi hat is equation number 13. In 1952, Bohm submitted the hypothesis that quantum mechanics admits hidden variables that are hidden in its formalism, but he failed to achieve explicit realization of the same. Further, non-existence of such variables was confirmed by Bayes' inequalities. Bayes' first inequality essentially states that system of point-like particles don't admit classical counterparts. Santilli showed that hadronic inequalities state that systems of extended particles with spin half represented via the isotopic branch of hadronic mechanics do admit classical counterparts. And Santilli finally resolved the problem in 1995 when he proved that hidden variables do exist within the context of hadronic mechanics. They are, in fact, hidden in the axiom of associativity of quantum mechanics and are quantitatively represented by isotopic element S hat equal to lambda. And the iso product is defined in this manner with iso associativity given by the last equation. The isotopic SU2 spin symmetry for extended particles immersed within dense hadronic medium admits an explicit and concrete realization of hidden variables of the type. So hidden variable is T hat here, defined in this manner with determinant of T hat is equal to 1, equation number 12. So condition on isotopic element T hat. The isotopic element T hat is much smaller than 1, as it has been the case for synthesis of neutron from hydrogen in the core of stars, the representation of nuclear magnetic moments and spin, new clean energies, and other applications. So the Santilli's contribution has shown that extended particles in interior dynamical systems appear to progressively recover classical determinism with the increase of density and other characteristics. And the spatial isotopic element T hat called as Santillian. T hat was called as Santillian, and ISO unit is compatible with the studies of determinism. Opposition to the argument. Primary opposition against EPR argument was upholding of uncertainty principle formulated by Heisenberg in 1927, according to which the position and momentum of the said electron cannot both be measured exactly at the same time. So delta R and delta P being standard deviations, the uncertainty principle is written as delta R into delta P is greater than or equal to 1 by 2h, equation number 14. And for the first time, Santilli defined isostandard deviations for iso-coordinates and iso-momenta, where delta R hat is the standard deviation for a position, and delta P hat is the iso-standard deviation for momentum. And the product delta R hat, delta P hat is given by delta R, delta P I hat, where I hat is the iso unit as defined by Santilli, giving this last equation, that is 15. So isodeterministic principle is obtained from this, and by eliminating iso unit I hat, we get delta R delta P equal to this integral, which is equal to T hat, which is much less than 1 as derived by Santilli, which is quite true, as isotopic element T hat has values less than 1. It has also been observed that the ISO standard ISO deviations tend to 0 when t hat tends to 0. See the equation 17. And this confirms deterministic principle 16. So the main result of this paper is that standard deviations of coordinates and momenta for particles within a hyperdense media are characterized by isotopic element that always being smaller, much smaller than 1, reduces the uncertainties in a way inversely proportional to a nonlinear increase of density, pressure, temperature, and other characteristics of the medium, while admitting the value t hat equal to 0 under extreme limit conditions, with ensuing recovery of full determinism as proposed by A. Einstein, B. Podolsky, and N. Rosen. Finally, the indeterministic principle, isodeterministic principle, as did finally the isodeterministic principle as derived by Santilli can be stated in this manner. The product of iso standard iso deviations for iso coordinates delta r hat and iso momenta delta p hat, as well as the individual iso deviations, progressively approach classical determinism for extended particles in the interior of hadrons, nuclei, and stars, and achieve classical determinism at the extreme densities in the interior of gravitational collapse. The study of neutron synthesis via hadronic mechanics under iso uncertainty principle allows a quantitative representation of neutron synthesis from hydrogen with far-reaching advances that cannot be formulated in quantum mechanics, let alone be treated. Number one, the prediction of mass for recycling radioactive nuclear waste by nuclear power plants via new stimulated decays. The possible return to continuous creation of matter in universe and to explain missing energy in neutron synthesis. The apparent reduction of all matter in the universe to protons and electrons. Concluding this talk, most modern mathematical methods proposed by R.M. Santilli point towards determinism in the limiting sense. Thus, latest science and oldest wisdom do have region of overlapping that needs to be explored with proper scientific spirit. In a way, Indian spirituality is being supported by modern scientific theory. These are the references. Thank you for watching.